This question I'd put in the hard category. They're asking us to find the sine of this angle here, sine C, which will involve an opposite and a hypotenuse. The sine of C is the opposite divided by the hypotenuse. But we know no dimensions. All we know are the two facts that D is a point on AB, which is this guy here, such that AD, this bit, is 3 times this bit. And we're also told AC is 2 times this bit. All the measurements in the triangle lead back to dB. So let's call that distance x. We don't know it, so give it a letter. Using this first relationship, AD is 3 times x. So this is 3x. And AC is 2 times this. So this is 2x. Suddenly the problem isn't half as bad. As I said before, we're going to need the opposite divided by the hypotenuse if we want to find the sine of C. But we don't know the hypotenuse. But Pythagoras will find it for us. So if I call this side h for hypotenuse, I could say h squared must be equal to this side squared. So this side is now 4x. So this will be 16x squared plus AC squared, which will be 4x squared. So therefore, h squared will be equal to 20x squared. And therefore, h is equal to the root of 20. I'm glad that's appeared because here it is in the answer, x. When you take a square root, it is always plus or minus, but h is a positive distance, so I'm rejecting the negative version of our square root. So therefore I can say that sine C is equal to the opposite, which is 4x, over root 20x, and the x's will cancel, leaving 4 over the root of 20. And if we compare that with the question's value for sine C, and therefore I can say that k is equal to 4. And that is your answer.